This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, so we're back again, and we've seen how all the measuring devices work. We've seen how a Vernier Calliper works. We've seen how a micrometer screw gauge works. So today we'll be talking about some of the more complicated things here. We'll be talking about the zero error. Now, what is a zero error? Let's take an example of a zero error. For example, there's this thing that you want to measure. There's this object, this rectangular object, and you want to measure its height, its length. Sorry, you're going to measure the length. So what you do is that you put a ruler simply right here, right at the edge. For example, this is, I'm sorry for the uniform edges, but we'll just go with them. For example, this is your zero mark. You put it, this is the zero mark on the ruler. You put it right here, and this is, for example, the 5 mark. The mark that says 5. Okay, so I've just magnified it. Failed attempt, but yes. So I can, and if this scale says centimeters, so I can safely say that the final reading is 5 centimeters. The initial reading is 0 centimeters. So the length would be just the difference of the final reading and the initial reading, which would be, in this case, 5 centimeters. However, this is because I have kept the edge of this object in line with the zero mark here. However, if a situation like this arises, for example, you say, I have again a rectangular object, and I want to find its length, and I don't know why I'm calling it height again and again, but it's the length. Okay, so now I'm not keeping the scale, the ruler's zero mark in line with this. I am the length is the same. We know that from the inside we know that the length is 5 centimeter as measured, but we're just trying to check our stuff. So if I keep the ruler here, and it goes like this, the ruler, we keep this in line with the 1 centimeter mark. Here, scale is in centimeter again. So since it's 5 centimeters, so it would definitely be on the 6 centimeter mark. Now, if I see this situation, I cannot just directly go and say that the length of this object is 6 centimeters. No. Why? Because the initial position is not 1 centimeter. It's not 0 centimeter initially. It's initially 1 centimeters. So what I'll have to do is I'll have to get the final length. This is not right. To get the final length, I will have to subtract the final reading with the initial reading to get the exact length, which would be 6 minus 1, giving us 5 centimeters again, which would be very true here. So this is the zero error, that I am not starting initially, I'm not keeping it in line with the zero mark here. So this is the zero error. So because of this, sometimes there are some errors introduced. For example, here if I started it, for example, let me take another color, and for example I started it from a little point here, another object, and till here. For example, this is 5 mark, 5 centimeters mark, and it ended up here. Now if I just simply write, for example, this is, let's assume this is 5.2. if I just simply write the answer to this question as 5.2 centimeters, it would be marked wrong because the reading did not start from 0 centimeter. It actually started from 0.2, for example. So what I'll have to do, I'll have to take this thing in consideration, otherwise it will introduce an inaccuracy in my answer. So I'll have to say 5.2 minus 0.2, this will give me a 5 centimeters. So this is the correct reading. So that is what a zero error is actually. That when it is a situation when the zero of your instrument is not exactly coinciding with the initial point, the very first point of the object being measured. Or in other cases, in the vernier calipers, as we will see, in the vernier calipers or in the micrometer screw gauge, when we just close it without the object inside, it will not be showing us a 0 initially when it should, because there is no object in between. It should show me a 0, but it will not, and that is when I know it's a zero error. So today we'll be talking about zero errors on vernier calipers. So let me just write it here, zero error on a vernier calipers. Okay. So there are two kinds of zero errors. Now what is happening exactly when there's no object in between and I just slide the vernier scale like this, something like this. These are the claws and these are closed fully. These are fully closed. This is something like a vernier caliper here. This is the tightening clamp. This is something like a vernier caliper. And when I'm closing it, when I just move it like this and I'm closing it, the reading should show me, if this is the main scale and this is the vernier scale, the vernier scale's 0 should coincide with the 0 on the main scale. If this is a 0 on the main scale, this 0 should coincide with it. If there is nothing in between, that is the rule. But sometimes, because of they are used very roughly in our laboratories, so sometimes that does not happen. What happens is that this 0, when we close it and we tighten the clamp, this 0 is somewhere here, or probably somewhere here, signifying that there is a zero error. So the readings will not be accurate. Now what to do in this situation? There are two kinds of zero errors that we will be talking about here. One is the positive zero error and one is the negative zero error. So let's talk about the positive one first. I will be talking about the positive zero error now. Okay, so let's see. I have a picture here with me. In this picture, I have closed the vernier scale and there's nothing in between the two, in the two jaws, and it's just, they're perfectly fit, and I've tightened the clamp, and yet I am having this situation. This 0 should be in line with this 0, but it's not in this case. That means that this is a positive zero error. The vernier scale 0 is on the right hand side of the main scale 0. This shows a positive zero error. Now I will have to find out the zero error here. For example, now what I'll do is I will see which line on the vernier scale coincides with a mark on the main scale. Which mark on the vernier scale coincides with a mark on the main scale? Let's see. This one, no. This one, no. This one, no. This one, no. No, no, no. And yes, this one, yes. So which mark is it? 6th, 7th, and 8th mark. The 8th mark is coinciding with a mark on the main scale. So a positive zero error means that there is already some reading. There is already a little bit of reading when I'm closing it. So you can see here, we are already ahead in this case. So what I will do, I will see, we just saw that the 8th mark was coinciding. So I will say the 8th mark is coinciding. So 8th mark times the accuracy of the Vernier scale, which was, since this is in millimeters, so 0.1 millimeters. This would be 0.8 millimeters. So all my readings will be 0.8 millimeters ahead of the actual value. This is a plus 0.8 error, I will say. Now, for example, if I get a reading on the Vernier scale, which we have seen the method, and I get an answer which says 17.6 millimeters. This is my final answer. With this zero error, this means that this reading is 0.8 millimeters ahead of the original reading. It's 0.8 millimeters more than the original reading. So in the case of a positive zero error, it means that we are ahead of the original reading. We already have a reading before we even started. So what I have to do, I will have to subtract this zero error from my reading to get the accurate answer. So what I'll do, I'll just 17.6 millimeters, I'll just subtract the 2. If you use your calculator, you will see the answer is 16.8 millimeters. So this is my final answer instead. It is always a good practice to check for the zero error when you are starting with your calculations. This is a positive zero error, and in a positive zero error, it means you were ahead of the original reading before you even started. So you will have to subtract it from the original reading. So to check whether you were having a positive zero error or a negative zero error, just remember this, that whenever the zero mark on the Vernier scale is on the right side of the main scale, it's always a positive zero error, like in this scenario. It's on the right side of the main scale, so it is a positive zero error. Let's move on to the negative zero error. Let me change the color of, I have very limited color chalks. So for now, negative zero error. Now a negative zero error looks something like this. Now I'm closing the jaws of the Vernier calipers, and they are fully closed, and I've tightened the clamp as in the screw on the top, and now I'm having a reading like this. The zeros are not coinciding, obviously, since we know it's the zero error. This shows me that it's a zero error. But what kind of zero error? The Vernier scale zero mark is on the left hand side of the main scale. Zero mark. This means it's a negative zero error. This means that before we even started, we were on the negative side. As in, if there was, before we even started, there was this little distance that it had to cover to get to the zero mark. So the Vernier scale covered this little distance first, and then it showed me the origin. For example, if this was 5, so it covered this x distance first, it came here, and then it covered this distance. So basically, the Vernier scale did not cover only 5 millimeters. It covered 5 plus x millimeters. There was some distance, some little distance here that it covered, and we should take that into account if we need to get accurate readings. Let's see here. The method is the same for the negative zero error. Just find out the mark on the Vernier scale which coincides perfectly with a reading on the main scale. Let's see, this one, no. This one, no. this one no, this one no, this one no, 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 yes, this one. And this is again the 8th reading here, the 8th mark. So if you can see, this is in perfect line. So we have a zero error of 0 point, as in we'll start it like again, 8th mark multiplied by the accuracy, which is 0.1 millimeters, and this would become 0.8 millimeters. So we have a zero error of 0.8 millimeters. Since it is a negative zero error, we will say that it is a zero error of minus 8 millimeters. It was minus 0.8 millimeters lagging behind the actual zero. So it had to cover that extra 0.8 millimeters first, and then reach to the reading. So for example, in a case, if I'm getting a reading of 7.6 millimeters and I have a negative zero error that I have checked initially, so this means that it first covered the 0.8 millimeters distance and then covered 7.6 millimeters. So what I will do to get the final reading, I will add the 2 up, because this is actually the distance that it has covered. So I will add the 2 up to get the final reading, which would be in this case 8.4 millimeters, and this would be pretty accurate. So it's always a good practice to check for the zero errors. Now let me give you a review again of what we have learned in this video. If initially when you have tightened the screw and jaws are perfectly fitting, there's nothing in between, if the vernier scale reading is on the right hand side to the main scale reading, as in the 0 of the main scale is here and the 0 of the vernier scale is here initially, this means there is a positive zero error, and all your readings you will find out the zero error with the same manner. You will see which mark is coinciding perfectly with a mark on the main scale. You will take that mark. For example, if I say this is the 5th mark, you will multiply it with the accuracy and you will get your zero error. Once you have the zero error, you will always subtract the zero error from your readings. And I call it a plus 0.5 millimeters. Some of the people also take it as negative since you were subtracting it, so they take it as a minus 0.5 millimeters. For my convenience, I remember it that way. So it totally depends on your convenience. If you want to call it plus 0.5 millimeters or minus 0.5 millimeters, it will be alright. No problem, as long as you identify the problem and you know that you have to subtract this value from your usual values. So yes, it's completely alright. So you will subtract this from your the zero error from your readings, and that would be your final answer. However, if the vernier scale is on the vernier scale reading is on the left hand side of the main scale reading, for example, in such a situation, initially this is the main scale and this is the vernier scale. So if this is the situation, you have a negative zero error. And for example, and you will find the zero error, for example, again with the same method to find the 2 points coinciding, and you will take that point. For example, if this is the 4th mark, you will say 4th mark times 0.1 millimeters. So the negative zero error is negative minus 0.4 millimeters. Now what you will do, you will just add the reading. You will, in all your readings, you will just simply add the negative zero error For example, if your reading is 18.6 millimeters, you will just simply add a 0.4 millimeters and your answer would be 19.00 millimeters or 19.0 millimeters. Since we have seen we cannot reach this digit of accuracy using our vernier calipers. For that we use a micrometer screw gauge.